So what kinds of distributions can we have before so let me just, yeah. So this, we already see this distribution right here. It is called the normal distribution, but that is not all the distributions that we can have. We can also have a skewed left distribution. A distribution can be skewed left, and those who are attending class, they know that the causes of skewness is outlier. An outlier, a small outlier, can cause a distribution to skew left. And what do I mean by skewing? It just means that if you draw a histogram, the histogram can just be like this. The histogram can just be like that. By the time it finishes, if you look at it, the tail is on the left. Whenever there is a histogram like this, and you superimpose a curve on it, a density curve on it, the density curve is skewed left. And when you calculate the mean, if you dive in, you will notice that the mean is less than the median. The median is Q2, like we have already talked about. The second quartile is the median. Anyway, so whenever a distribution is skewed left, in other words, when the histogram has a tail on the left, then the mean is less than the median. And by the way, an outlier causes that skewness. And when a distribution skews right, I'm going to draw something like that. So this means that when I superimpose, see, if I draw actually a histogram inside this, you see what I'm talking about? So the histogram, you can see that if you superimpose a curve on it, it's going to have a tail at the right. So whenever a distribution has a tail at the right, you will say it is skewed right. Skewed right. Skewed right. R-I-G-E, G-H-T. And this is skewed left. So we already know that skewed left is the same as negatively skewed, just in case you are told to show a negatively skewed distribution. It's the same as skewed left. So negatively skewed. If it is skewed right, it's positively skewed. So that's a name, positively skewed. Okay, anyway, when it is positively skewed, then there's an outlier at the right. The mean X bar is greater than the median. So in a test and the pretest, you will see a question on skewness. And then you will be expected to find the mean, find the median, and then compare them. If the mean is greater, skewed right. If the mean is greater than the median. Remember that the median is the same as the 50th percentile or second quartile. All right. Okay. So when the mean is equal to the median, we say that the data is bell-shaped. And that's what we're talking about today. Whenever the mean is equal to the median, then the distribution is bell-shaped. That means mean is equal to the median. So far, I hope what I'm saying is clear. Then, if a distribution is bell-shaped, we say it is normally distributed. We can call it a normal curve. There are so many properties of normal distribution, and we're starting to talk about them today. And by the way, statistics is about normal distribution. Statistics is about normal distribution. Okay, so whenever after unit 3, we will not actually be talking about skewed left and skewed right. That's also what is called uniform distribution. In the uniform distribution, it looks like this. It's a situation where everybody is the president of the United States. You give a test, everybody in the class made 100, but it doesn't happen like that. And there's no way everybody can be the president of the United States. And there's no way everybody can be the principal. You see? So uniform distribution doesn't really happen. But anyway, somebody talks about them. It's not a reality. Okay. Skewed right and skewed left are not used for statistics. By the time you get to unit 4, which is inferential statistics, confidence interval hypothesis testing, by the time you start doing your thesis in your school, your university, you will be using a normal distribution to do your thesis. Okay, so I'm going to clean all the other scribbles so I can focus on normal distribution. Now we are focusing today on normal distribution, and we are starting with the properties of normal distribution. We want to start with the most important property. The most important property of normal distribution is called it uses empirical rule. The empirical rule. Empirical. Another thing, empirical rule says, by the way, the normal distribution contains 100%. So we also call it area. So area under the normal curve is 100%. If you want to work in percent or 1. And by the way, the other day, last week, we calculated the frequency, relative frequency, and cumulative relative frequency. And I might have to go back to that. But the total cumulative relative frequency is always 100% or 1. And so I said that we will be bringing it to normal distribution. The total area under the normal distribution is 1. Okay. So let's write it as property number 2. Property number 2. All these properties are in a book. So you can look it up. Property of normal distribution. So area under the normal curve is 1. Area is 1. I'll just be using shortcuts. And the normal curve uses what is called z-score. The normal curve uses z-score. And the mean and the median, by the way, remember we said that the mean of a sample is called characteristic. Characteristic of a sample is statistic. So the mean of a sample is x bar. And we also said that the mean of a population is called mu. Mean of a population is mu. Mu, it's a Latin word. Okay. And the mean of a population is a parameter because we already said that the characteristics of a population are called parameters. So if I am given a population, then all the characteristics of the variables that I will do will be parameters. Like if I calculate the mean, if I calculate the standard deviation will be like this. If I calculate the variance will be sigma squared, and so on. But if I'm working with sample, then I have sample standard deviation S of X. If I am working with sample, then the variance of a standard deviation this is X squared. All right. So anyway, let's go back to, so a sample can actually be normally distributed. That's why I went to make sure I said what I said before. A sample can be normally distributed. A population can be normally distributed. Some samples can be normally distributed. And if a sample is normally distributed, then the population that it comes from is also normally distributed. All right, let's keep writing the properties of normal distribution. So it uses z-score. Area under normal curve is 1. Number 4, I'm not going to write a lot of them because just a few. Number 4, the mean is equal to the median. If it is H bar, which means your sample, mean is equal to the median in any normal distribution. And it is bell-shaped. Number 5, bell-shaped. I am actually, and when a data is bell-shaped, we also say it is normally distributed. All right, so we will try and explain the first one. What is the meaning of empirical rule? We just wrote 5 properties of normal distribution. The first one is empirical rule. Normal curve obeys empirical rule. Number 2, area under the normal curve is 1. Number 3, it obeys z-score. If it is not normally distributed, that is, if it's skewed right or left, we don't use z-score. There's something called Chebyshev's inequality that he used. We're not getting into that. Chebyshev's inequality is not in our syllabus, and I'm not going to be covering that. All right. So, but anyway, skewed data use Chebyshev's inequality, and that's all we're going to say about it. It's not in our test, but normal curve will be in our test. Normal curve uses z-score. All right. The mean of a normal curve is equal to the median. Normal curves are bell-shaped. If you see a density curve, if you see a histogram of a normal curve and you superimpose a density curve on it, it looks bell-shaped. Okay, so we are going to start with the first property. Now we are just going to talk about the first property for now. And there are videos also. The book has videos. I will make a video on how to watch the author's video, because the author has videos too. Author of our book. Okay. The empirical rule is actually called 68, 95, 99.7 rule, and these are all percents: 68%, 95%, 99.7%. So empirical rule can be called 68, 95, 99%. And this empirical rule says for any data under a normal curve, 68% of the center, 68% of the center lie within one standard deviation. So this, let me make it bigger. Let me bring it up so that you can see it better. So let me pull this up a little bit. No, I still want to. All right, so I don't want to make it. Okay. Okay, I just want to, let me draw up. Let me make it up. I'm going to make it up so that way. Okay, So this is what I'm saying, even though I'm drawing somewhere else. The empirical rule says that in every normal distribution, 68% of the data lie between 1 plus or minus 1 standard deviation. So minus 1 standard deviation on the left, plus 1 standard deviation on the right, plus or minus. Within means plus or minus. So this is 68. And it says that 95% of the data on the normal curve lies within plus or minus 2 standard deviation. So let's write 95% here. So 95% of the data lies within plus or minus 2 standard deviation, sigma 2 sigma, negative 2 sigma. And 99.7% lie within 3 standard deviations. So I'm going to draw this with black. So this is minus 3 standard deviation on the left. This is plus 3 standard deviation on the right. So 99.7. In other words, if you calculate the distance between this plus or minus, this is minus 3 standard deviations. I hope you know that 3 standard deviations is called Z also, 3Z, but later on we shall. And this is 3 standard deviations. All right, so now I am going to our practice test. So we see a question. What kind of question? What kind of question will focus on this empirical rule so that we shall come back? So let me get a question that is talking about empirical rule. And so we answer the question. Now we know that the question is already in our test, by the way. Question on empirical rule is already in our test. I hope I can find it. All right. Yes, I found it right here. Okay, so question number 25 in our test, practice test. But this question, because I'm going to reshuffle this practice test, when I give it to you in a test, it's still going to be, those numbers will be switched around. 82 might be 28. Number 25 can be number 1. The numbers will not be the same. So I hope nobody's going to memorize the answers of the practice test. And by the way, if you scroll down, you see that the practice test has answers. See, these are the answers. So when you finish, you check yourself. So let's go back to number 25. And I want to make it bigger that way. So I want to make this bigger. All right. So now we want to, I'm going to draw a normal curve and try to answer the questions here. First of all, I need to read the question. Let me read the question and see what it's saying. It said, and by the way, questions on normal distribution are always going to be real world questions. A lot of questions in your SAT, SCT are normal distribution questions. All right, so I'm going to draw a normal curve though. This is a normal curve. I'm going to make a sketch. It's not going to look normal. It's going to look a little bit crooked. That's okay. So that's my normal curve. Because I know it's normal curve, the mean is at the center. So the mean, and by the way, I will assume that this is a population, so that I will use mu to define the mean. But by the way, mean is equal to median. So mean is a mean and median are on the middle. And that line is the line of symmetry. Hopefully my normal distribution doesn't look accurate, but that is a line that divides the normal curve into 2 equal parts. And by the way, since the total area under the normal curve is 100%, then 50% of the normal curve lies on the left, 50% of the normal curve lies on the right. Okay. The normal curve is actually counted in terms of z. So let me use another color. So one standard deviation on the left. And by the way, let me assume, okay, let's use this question. Let's not assume anything. Scores on an IQ test have a bell-shaped distribution with the mean of 100. So mean is equal to 100. And the median will be equal to 100 also. And the standard deviation is 18. Use the empirical rule to determine the following. Remember, the empirical rule says 68% of any data in a normal distribution lies within one standard deviation, plus or minus one standard deviation. In other words, I'm going to write one standard deviation here. So 1z. I'm going to write 1z. 95%. That's what we just saw before. Lie within plus or minus 2 standard deviations. And 99.7. That's the rule. That is the empirical rule. This is just one of the properties of normal curve. It lies within plus or minus 3 standard deviations. All right. So, and they gave me that one standard deviation is 18. Therefore, I hope you remember that the mean is 18. So, since one standard deviation is 18, if anybody has an IQ of one standard deviation below the mean, then it is 100 minus 18 because the standard deviation is 18. So 100 minus 18. And 100 minus 18 is 82. Therefore, this is 82. This person here who has IQ of 82 actually has one standard deviation below the mean. Okay, what if somebody has one standard deviation above the mean? So that will be 100 plus 18 then. So one standard deviation above the mean is 100 plus 18. That is 118. So one standard deviation above the mean is 118. Let's answer question number 1. Question A. Everybody look. Let's answer question A. What percentage of people has an IQ between 82 and 118? We just found them. Well, guess what? The empirical rule told us the answer already. So the percentage of people who has between one standard deviation below the mean and one standard deviation above the mean is 68. So you don't have to use your calculator. I will show you how to use your calculator though, but because it's not always going to be one standard deviation above the mean and one below the mean. Sometimes they will ask you what is the area between somebody who has 0.1 standard deviation below the mean and 0.1 above. So for now, we're just following empirical rule. An empirical rule are on integers, plus or minus 1 standard deviation. We will use our calculator to check and see if this is correct. Later on, we're going to use a calculator. I'll show you the formula. I'll show you the formula so that you know how to calculate it when it's no longer, when it becomes a fraction, because very soon it's going to become a fraction. Let me see, are we together? Do you follow what I just said about A? So we just answered question number A. According to empirical rule, it is 1 standard deviation below the mean and 1 above the mean. Therefore, according to empirical rule, is 68%. Because the question says, what percentage of people has IQ score between 82 and 118? But we are almost given the answer. We are told that the standard deviation is 18. So mean minus 18 is 82. Mean plus 18 is 118. And exactly 118 and 82 are here. Therefore, according to empirical rule, it is the percentage is 68%.